I'm Paulina, and I work in Software Mention. Software Mention is a software development company from Kraków, Poland, and you probably may know us from our React Native open source activities. Last year, well, if you don't know us, I encourage you to follow us on Twitter or just check out our website. I'm gonna email you all all the links. I can see the comments. Thank you. What else? A year ago, we started Software Mention Academy as a way to share our knowledge about React Native. And we also invite super talented and skilled engineers like Lydia and Evan. Okay, what else should I tell you? Software Mention Academy is supported by Shopify, so thank you, Shopify, for helping us. Well, you should also know that if you have to go at any time, you can watch the replay of this webinar almost immediately after the webinar is finished. And also, you can ask the questions in the Ask a Question. It's like below the screen. You can use this feature to ask the question and vote for the most popular ones. And then Evan and Lydia will answer them live after the webinar is ended. I think you can also ask the questions in the chat, and they will be answering them like on the go. So I think this is it. And I'm going to give the stage to our hosts, and they're going to tell you a little bit more about themselves. So, yep.
All right, so I'm Evan, and this is Lydia Hallie, the avocoder. And today we're going to be talking about like React Native for native developers. We have a video prepared, you know, in case there was any like transitive issues that occurred, like maybe what just happened, a great demonstration of what could happen. So we're going to play that video. Yeah, it is the avocado.
Try to play that video.
Yeah.
Yes.
And also we just have it for later, so it'll be much higher quality if you guys want to see it played back. But of course, watching it live is awesome too. So I'm going to go ahead and play that now, unless you have anything else you want to add.
Nope, I think we cover it in the video.
Okay, sweet. All right, switching over now.
Hopefully.
Yeah, hopefully.
Hi everyone, I'm Lydia Hallie, a JavaScript engineer.
And I'm Evan Bacon. I work on Expo, React Native, and React Native for Web.
And in this webinar, we'll walk you through everything you need to know in order to get started with React Native and feel comfortable developing your first native app. And although this webinar isn't only for web developers, we will often compare the native parts to the web development parts in order to show you how you can apply your existing skills when working with React Native. First, let's take a step back in order to understand what React Native actually is and why it was created in the first place. To do this, let's take a look at native development without using React Native first. If we want to build a successful native app, it needs to be accessible to both iOS and Android users. However, iOS and Android apps are written in completely different languages. iOS uses Swift or Objective-C, and Android uses Java or Kotlin. We essentially have to create two separate but identical applications, which more often than not means having two separate engineering teams in order to develop and maintain them. It can become increasingly difficult to keep the UI and features in sync on both platforms, maintain them, pay the engineering teams, and so on. This is where React Native comes into play, because instead of having to write the same app multiple times, we can write the app once and run it on different operating systems, all using React. This means that, for the most part, we no longer require a deep understanding of Objective-C or Java in order to be effective mobile developers. Instead, we can use our existing knowledge of React, JavaScript, and other web development tools in order to create cross-platform apps. You can even reuse your React Native components to build web applications, which is something that many massive websites like Twitter do. This means that our single code base can run on iOS, Android, and web. So let's take a look at how React Native is able to do all this. First, let's clarify some terms. You can divide React into three parts: React Core, the renderer, and the reconciler that's within the renderer. React Core exposes some methods, such as createElement, that's used in order to create React elements. A React element is just an object that virtually describes a component that we created. React Core itself is not responsible for actually rendering anything to a screen. That's the job of another part of React, namely the renderer. If you've built websites with React before, you've probably used the React DOM renderer to render your components to the screen. We can pass the React elements to the render method, which then renders the contents to the screen based on an HTML element that we provided. When using React Native, we're still using React Core to create our React elements. This time, we use the React Native renderer instead of React DOM. Whereas React DOM only cares about a browser environment, React Native needs to be able to create native components based on the React elements that we created. React Native is actually split up into two parts, a JavaScript part and a native part. The two parts can interact with each other with something called a bridge. When our JavaScript bundle is executed, React Native sends commands over the bridge to its native module. These commands are JSON objects that the native version uses in order to actually render the components as views on the device. The third part of React is the reconciler, which contains a diffing algorithm that uses a virtual representation of our layout in order to determine what parts of our UI need to be updated based on its current and next state. This works the same on web and native, as you may be familiar with the virtual DOM. In React Native, the virtual DOM is usually referred to as the shadow tree, but it's the same concept. The biggest difference between React DOM and React Native is the way that the content is rendered to the screen. In the browser, we write HTML elements, which are parsed, interpreted, and then drawn to the screen by a custom rendering engine that's within the browser. React Native works in a similar fashion by outputting native views, which the platform renders in the most optimal way possible. This concept is pretty unique to React Native. When people say build a truly native app with React, this is what they mean. We actually create apps that run fully native code in order to render the views. For styling, instead of CSS, React Native uses a performant custom native version of Flexbox called Yoga. We don't have access to all the style properties that we have access to with CSS, but it also provides some custom styles. There are also extremely powerful gesture and animation libraries that you can use with React Native, like Reanimated, which was made by the software mention team. When we make a website, we often don't think about some of the native functionality that browsers provide for us, as we have little to no control over how these interfaces work. A good example of this is the navigator, and in this case, especially the geolocation value. When we want to access this value, the navigator has access to the native GPS code on the device that you're running. In iOS Safari, it has to use core location, and on Android browsers, it has to use Location Manager. However, when we use navigator.geolocation, we don't have to think about this ourselves. The browser takes care of it for us. APIs in React Native apps are very similar to this, as modules have to be able to run on different operating systems. For example, a custom native modules.location module can give us access to the core location API that's available on iOS and the Location Manager API on Android devices. A difference between web and native here is the amount of control that you have over the module. We can modify the behavior of our own API, since we can rebuild the React Native app that contains this logic. But we wouldn't rebuild Chromium, unless you're part of the Chromium engineering team. Now that we've covered how React Native works and the problems that it solves, let's take a look at how we can actually start developing a native React app. The simplest way to initialize a React Native app is by using the Expo CLI, which we can install globally. After that's done, we can bootstrap an app with the expo init command. This generates a blank app for us and shows us some commands that we can work with in order to run your app on the platforms that Expo supports. For example, we can run yarn Android in order to run it on an Android emulator, or run yarn iOS to run it on an iOS simulator, and yarn web in order to run it in the browser. Let's cd into the project that we just created in order to actually see what happens when we start the local server. After running expo start, expo shows us the similar commands as we saw before in order to make it easy for us to run our app on the different platforms. To run it locally, you can use I to start your project on iOS, A to start it on Android, and W to start it on web. The yarn start command starts a server under the hood, which hosts our transpiled JavaScript code and assets, just like on web. This simple HTTP server has some custom middleware that a browser or app can use in order to interact with the Metro bundler. You can easily open the project in VS Code by pressing O. And from here on, we can start making changes in our codebase. We can save it, and we can watch it update instantly on all running devices using React Refresh. We can also see some of the files that are generated and available on the server. When we visit the root URL, we will see the manifest.json. The manifest dictates the name of our app, the icon, some development fields like where to send the development logs, and so on. You can see the manifest.json as Expo's equivalent to the index.html that we need in order to run a website. It's basically the root file that is used in order to tell the client where to load the code from. Besides the properties that we just mentioned, we also have a bundle URL, which specifies where the server is hosting a JavaScript bundle. This is kind of equivalent to the value of the source attribute in a script tag in an HTML file. The bundle URL is made up of the file path that's relative to the root of your project, for example, app.bundle. This is the transpiled version of the file with the JS extension. You may notice that it takes a while before this file is loaded. This happens since the Metro bundler only starts getting the bundle ready when it's actually requested. To the transpiled version, we can add query parameters that specify how the file is bundled, for example, minify or dev. This changes the way that the bundler presents the code. The only required parameter is platform. This parameter specifies the platform that it should run on, for example, iOS, which contains a single JavaScript file that gets fetched on iOS devices. The same would happen if we changed iOS to Android. This difference between the platforms is necessary since both platforms support different file extensions. Let's say that you have a file called index.js and a file called index.ios.js. In that case, the index.ios.js file will be prioritized over the index.js file when running on iOS. The same happens with Android and web. Let's see what other files are necessary in order to run our project. Although the file structure is fairly similar to what you might be used to when initializing a React DOM app, there are a few config files that are also used in order to configure how our app runs and looks. Firstly, we have babel.config.js. Babel is used by the Metro bundler in order to transform our code, eliminate dead code, and so on. This ensures that your app can run on more devices, which is identical to what Webpack does in React DOM projects. You'll see that the Expo preset is added by default. This extends the React Native preset by adding web support and other optimizations that are used in order to create a performant production app. Then we have the metro.config.js file, which contains the configuration of the Metro bundler. You can compare this to the Webpack config when using Webpack. The Expo config is used by default. This is akin to create React app or create next app, which also use a default bundler config to improve the developer experience. For example, more use for errors that you can work with, since handling errors can be quite tricky when using React Native. This file isn't always defined though, and if Expo can find it, it will default to using Expo Metro config. Lastly, we have the app.json. This file is used to generate the manifest.json that we saw earlier, and also configure the native pre-build step, which we'll get into later. Long story short, this file dictates how Expo should generate your project's native code. Now we need a development client to interact with the app. On web, this would be the browser. Now that we have an app, let's add some features to it. Just like React DOM, React Native has a wide ecosystem of third-party packages. The biggest difference is that React Native packages can also ship native bindings in a module, which are typically found in a package's iOS and Android folder. If you install a package with native code, you will need to rebuild the native app before you can access the native code from your application code. If you're using the Expo Go app, however, you can only use the native modules that are compiled ahead of time. This means that if you're working in the Expo Go app, you need to use packages that are part of the Expo SDK, React Native, or a handful of other popular libraries, like Reanimated from Software Mention. To determine if a package works in Expo Go, you can refer to the React Native directory. The Expo SDK is a large collection of common native features, like notifications, video, audio, authentication, and so on. But it is missing certain native features that either require build time configuration, like in-app purchases, or secure features that the App Store has disallowed. This is great for getting started fast and for a lot of the development cycle, but eventually you may need to add some custom native code not included in Expo Go.
Traditional native development is very slow to do. This is because you have to compile and install all of the native code for your project basically every time that you make a change or install a new package. And that's not to mention tools like Xcode and Android Studio, which take a very long time to install and get set up properly and get acquainted with. So there's just a lot of things which are kind of roadblockers, especially if you're used to web development. iOS development on Windows and Linux computers is also not very doable because tools like xcode and the simulator are only available on Mac OS. So this is where Expo Go comes in. Expo Go is an app that you can download from the iOS App Store or Google Play Store or install directly on your simulator or emulators. And it's a pre-built native runtime. So think of this like a pre-built React Native app with a ton of native modules already installed on it. So this kind of cuts out the needing to rebuild or build an iOS or Android app until you need custom native code added to it. The way Expo Go works is you just open up an app, it connects to your local development server, and then it provides developer tools for doing things like reloading or fast refresh or debugging your code. You can open up your projects that you've previously published, and if you're on a team, you can also access other projects that your team is working on. So let's talk about how this actually works. When you run Expo Start, Expo CLI will open up a terminal and it will show a QR code in it. And you can scan that QR code with your phone camera, or you can enter the dev server URL directly into the Expo Go app. When we scan the QR code, it opens up a link, and this link you'll notice has the EXP URI scheme. This basically means that you should open it in the Expo Go app. If it had like HTTP or HTTPS, then you would open it up in a browser like Safari or Chrome. So here is an example of me using it. When I scan the app, I get a notification to open it. I open it in the Expo Go app, and it downloads the JavaScript, which effectively runs the app. And if I make any kind of change to my source code, it will update here immediately. Let's talk about what's going on behind the scenes when you open a URL in the Expo Go app. Expo Go is going to make a GET request to that URL, and then that's typically going to hit a development server that you're running on your computer. This often happens when you do Expo Start. Now that development server is going to serve up a manifest.json. Like Avocado mentioned earlier, this is like the index.html in a website. When Expo Go gets the manifest.json, it's going to parse through it until it finds the bundle URL property, which is like the script source attribute. It basically points to where the JavaScript can be fetched from. So Expo Go is going to make another GET request to the development server with that JavaScript URL. The development server is then going to tell Metro Bundler to bundle up your JavaScript and then send it over to the Expo Go app. After Expo Go downloads that JavaScript, it sends it to the native JavaScript engine, which effectively starts your app. And that's just a little look behind the scenes on what's going on. As you can see, there's a lot of similarities here between the developer experience you get with a web browser and with the Expo Go app. It's super important to mention that this is development only. It's not a distribution method due to platform restrictions with the App Store and Play Store. You can only distribute your app through the App Store and Google Play Store. We'll talk a lot more about that in depth here in a minute, but I just wanted to let you guys know that. So mostly you can only load development URLs. So let's talk about using custom code in our React Native application. If you're working in the Expo Go app, then you can use anything that's inside of the Expo SDK. This is stuff like updates, authentication, audio sensors, crypto. A ton of things are inside of the Expo SDK. You can also use anything inside of the current version of React Native that version of Expo SDK supports. So for instance, Expo SDK version 41 supports React Native version 63. So you can use anything in React Native 63 in the Expo SDK 41 project. So let's say we want to use a camera. We can install Expo Camera into our project, and we would just be doing that so we can get access to the JavaScript code that comes in the Expo Camera package. Because the native code that comes in the Expo Camera package was already compiled into the iOS and Android apps ahead of time before we shipped it to the App Store. But what if we want to add some custom native code that isn't inside of the Expo SDK and it wasn't shipped with Expo Go? How do we do that? Well, a great example is the library React Native Fast Image. We can install it in our project with yarn add React Native Fast Image, and then add the code here. And as you can see in the Expo Go app, it's not working because the native code isn't there. It can't find the React Native Fast Image view. So all we have to do to get this working is to create a custom development client by just building the application. And we can do this with a command called expo run iOS. Now, expo run iOS is actually a brand new command that I'm showing you guys here for the very first time. It's still in like a late beta, so to speak, but this is the first time I've shown anyone it publicly. So all we're going to do is run expo run iOS in the project, and we need to be doing this from a Mac OS computer. It's going to prompt us for our bundle identifier, and it has a nice suggested value. And this is going to generate all of the iOS native code required to make this project run. And no matter how complex our project was, it can generate all the native code for it. And then it's going to schedule an xcode build, which you can see here. And after the xcode build is done, it's going to start up the Metro bundler, open the simulator, and then open the app in the simulator. And just like that, you can see the application is running and we have access to React Native Fast Image. If we open it up in the switcher, you see it is its own app. It's not running in Expo Go. And if we switch back over to Expo Go, it will still just not be working. But if we commented this code out and went back to Expo Go, it would continue to work. So we can continue to run our app even after we've pre-built it. So something we're noting here is that the expo run iOS command has customized logs, which are super helpful for trying to determine how React Native actually works internally for Node developers. Here, for instance, we can see that the React Native Fast Image library pulled in the rn fast image CocoaPod, which included the ff fastimageview.m file, which is one of the native files inside of that package. But we can trace it back to which native module included it, which is helpful for us seeing like what kind of native modules include what files, or if we see an error, we can see which node module it traces back to. And we can also see like which node modules are accounting for more native files than other node modules. So we can determine if it's worth it to keep it in our project or not. The alternative to this is that you can run expo pre-build and then build your project with xcode if you'd like. I highly recommend not doing that because xcode is very not great, but you can use it if you'd like. So it is an option. So let's actually take a look at what's going on behind the scenes of Expo Run iOS. We're actually running Expo pre-build, and we only do this when there is no iOS folder in the project. And the same with the Android variation of this command. And what pre-build does, if we actually run it in our project, we can take a look at what's going on behind the scenes. You can see it's creating the native project directory, updating the package JSON, and then it's synchronizing the config. You can think of this kind of like a bundler for native apps in the sense that it's treating iOS and your Android folders kind of like these generated folders, where if you generate a production build with webpack, it's going to generate a build folder. And you can go in and modify that build folder directly if you want, but it's kind of recommended against since it's harder to work with. And then you lose out on the abilities of being able to generate the project again with your bundler. So that's just something to keep in mind. What's nice about pre-building, though, is that it is kind of sort of intended to be a fork in the road if you want. So you can continue to generate your projects if you want, which is kind of called the custom managed workflow, or you can modify your native project directly, which is the bare workflow in Expo. Now, the most powerful part of pre-build is the customization. Pre-build gives authors the ability to tap into the pre-build step and essentially customize the managed workflow. Now, pre-building is super new. It just came out in May 2021 with Expo SDK 41. So I am kind of giving you guys like one of the first demos of how it works internally and like what's going on. Now, config plugins, in conjunction with our auto-linking functionality, enables us to completely generate a complex native project from scratch and regenerate it if we need. So here's an example of a config plugin. It's a very basic function, all written for a Node.js environment, which accepts the Expo config, makes some modification to it, and then re-exports the config. We can define which plugins we want to use through the plugins array in the app.json or app.config.js in our project's root folder. So here you can see I'm using our custom plugin. I'm using the Expo Camera config plugin and the Expo Firebase core config plugin. Now, you can resolve from relative file paths, or you can resolve from modules which export a config plugin that is used to customize the functionality of your app for that library. So for instance, Expo Camera will customize your app to work with the camera native module. Now, a problem that we faced when adding config plugins was that config plugins need to be static and serializable. So we didn't have a way to give people asynchronous functions or just like a system to work kind of outside of what Expo config currently supports. So we created modifiers. Now, modifiers are essentially async functions which you can chain together to modify a singular file. So for instance, in this example, we're modifying the info plist as a JSON object. And this is really powerful because it gives library authors the ability to kind of step outside the lines and make any kind of customization that they need to the native project in order to make their library work. So when we run pre-build, we have a resolver which runs over the plugins array. It collects up all of the plugins, and then it attempts to resolve where the actual file is coming from. And this is where it'll throw any errors if something isn't right, or there's some maybe a syntax error, for instance. After the plugins are collected, they're then run sequentially. So for instance, there's a with icons plugin, which is provided by Expo CLI, and that creates all the icons for your iOS and Android app. Then there's a with camera plugin, which is provided in that Expo camera package. And this adds the required permissions so that your app doesn't crash, things on Android manifest and things on the info plist. And then there's the with firebase plugin, which comes in the Expo Firebase core package. And this includes your Google services file and basically ensures that the native Firebase code has everything it needs to run correctly. And when all of the plugins have been executed and the modifiers have all been evaluated, then the pre-build is complete. What we're left with is an iOS and an Android project, which are fully capable of running all of the native code that was added to our project at the time of running pre-build. So it's very exciting stuff. So the alternative to this is manual installation, which is a lot less fun, to say the least. Like you have to go through every package's instructions, and you have to do things like add the Android manifest, the info plist changes, any kind of xcode changes, which is not fun, kind of unreliable and untested for your project. It's actually difficult to properly upgrade all the files that are in your projects. And so what we find is a lot of people just have like these artifacted features from when they started their project versus like the current state of React Native. So this definitely helps to get rid of that, because if your project is in a fully generated state, you can just clear your project and regenerate it with all of the updated code. So it definitely helps solve a lot of existing issues that we found in React Native development. And we're really excited for people to get out there and start trying it out. The Android equivalent of this command is called expo run Android. It does the same thing, prompts you for a package name, and it actually will tell you if the package name is already in use by a published app. Then it will pre-build just the Android code, open up the emulator, and then build the app. So over here you can see we have our project running in Expo client, and fast image isn't available for the Android Expo client. And just like that, we built it, started up Metro, and opened up the project in a brand new app. So it's very exciting. It's just like it just works, and you can very seamlessly glide between the managed workflow and the bare workflow with all of these commands.
Now that we've built our app, we want to get it into the hands of users. On web, we could simply do this by uploading the files in our build folder to a hosting provider like Netlify, Heroku, or Vercel, which then take care of the deployment for us. Anyone who has access to the internet can visit the website on the specified domain from any web browser. However, native apps work a bit differently. Think of deploying a React Native app like deploying a website and the browser that the users need in order to run that website. The browser portion, or the runtime, must be distributed through private services, such as Apple's App Store or Google's Play Store. Android is a bit more lenient when it comes to distribution, because you can literally just give the users the native app file, and they can install it on their device. Unfortunately, however, the only way we can distribute an app to everyone on iOS is through the Apple App Store.
All right, let's talk about deploying our app to the Google Play Store and Apple App Store, which is arguably one of the most important steps to making an app and one of the hardest steps to app development in general. So in React Native, it's a little different to web dev because you not only need to create the JavaScript bundle with all of your assets and everything in it, but you also need to create the native runtime around it. So in web dev, that would be like creating the browser and your app at the same time. Now, native builds and submissions actually got very easy very recently, like in the last few months, with a tool called EAS Build and another one called EAS Submit. And what these do is they manage many parts of your app building and your app submissions to essentially make it as easy to do native builds as it is to do things like web builds. It is still like a little bit more cumbersome, but it's way easier than it was before. So we're going to install the tool with npmi-g EAS CLI. Now, all we have to do to actually use EAS is run EAS build in our root folder. We're going to run EAS build, select all platforms. Now, this is going to create an Android key store, send our Android code up to the EAS build server, and then we're going to sign into our Apple developer account, and it's going to manage our certificates and create our provisioning profiles, synchronize our capabilities, basically do all of the code signing process automatically. All we have to do is just like keep hitting enter. And anyone who's had to do code signing manually knows that this is like groundbreaking. It's awesome. And when it's done, we're going to get 2 links for our builds. We can go to the Android one, the iOS one, and of course you can build for one platform at a time if you want. EAS build essentially takes all the code in our project, sends it up to the EAS build server where it runs in the cloud, and it essentially does an Android build in the cloud and then an iOS build in the cloud. And if it's a managed project, then it also runs pre-build before doing the builds. So no matter how you make your project, it eventually always runs through some kind of generation step, like pre-build before actually building. Now, while those are building the native binaries, it's also going to create the optimized JavaScript bundle and collect all the assets for our app using Metro. What Metro essentially does is it collects up all of the JavaScript in our project, and then it creates one big bundle out of it because Metro, especially in React Native, doesn't really do any kind of bundle splitting. And then it creates a platform-specific bundle from that. So one for iOS and then another one for Android. Now the native builds will run a script which essentially copies over this JavaScript bundle and the assets that Metro has just created and collected. And it embeds those assets inside of the native app binary. It does this for improved TTI or time to interaction and to support offline mode just by default in apps, because those 2 features are super important when developing an app. And then another copy of the JavaScript and assets are uploaded to Expo's static hosting service to make OTA updates possible. You can kind of think of Expo's static hosting service like Heroku or Netlify, but specifically for these React Native JavaScript bundles. And again, we're going to talk about this here in a moment. So this is the actual page for the build that I just made. And as you can see, I can download the IPA right from here. I'll just go ahead and do that. And then over here, I can look at the xcode build logs and other relevant information about the build that just took place. I can see that it took about 10 minutes to build this app and how long it will be available for. I can also check out the Android build page where we can see some additional details on the build, and we can download the APK if we want. So I'll go ahead and do that for deployment here in a minute. And then I can also look at the Gradle logs if I want. So if you want to, you can go through and see how everything built. All right, now that we actually have the IPA and the AAB file, which are the iOS and Android binaries respectively, and remember, we've only run one command so far, but we have the binary files downloaded. Now all we need to do is actually submit them to the Google Play Store and the Apple App Store. So I'm gonna do that right now. All right, so the first thing I'm gonna do is sign in to play.google.com. Gonna go to the console from my developer account, and this costs a one-time payment of $25 to use. So then we can create an app. We have to create an app. We can't do that automatically. Webinar, English, then you can select what kind of app it is. So an app or a game, and if it's free or if it's paid, and then you just confirm these other 2 things. You can read them or not. I am opting to have read them earlier. And now it's created our app entry. And all we have to do to get this actually in the store is go over here to the production tab, click create new release, and then hit continue. And now we can upload our AAB or APK files here. So I've got an AAB file right here. And that's basically it right there. All you have to do after that is select a name for the release, something like production, I guess, and then some release notes, and you can save it. And I think you might, when you do review release, it's going to prompt you to add some extra metadata. This is things like screenshots, your description, stuff of that nature. But for the most part, all of the heavy lifting is done. Everything else that we're gonna do from here on out to get this app to the Play Store is purely cosmetic. Now we just uploaded our app to the Google Play Store, and now we're gonna do the Apple App Store. And the iOS submissions are actually substantially easier than the Google Play submissions, believe it or not. Traditionally, it's actually way harder to submit to the App Store. But with EAS, there is just so much automation that it is incredible. But before we do that, I want to take a look inside of the IPA. So you can rename your IPA to a .zip folder and then open it up and check inside of it. And here's what you're going to find. And this is actually kind of interesting. So you get your splash screen over here, and then down here, this is your actual app binary. Right next to that is the main.js bundle. And this is the JavaScript file that Metro created during the EAS build process. It's the optimized JavaScript. You can open it up in VS Code and take a look at it if you want. And then we had the app.manifest. Now that was like the manifest JSON that we looked at earlier. And then we also have stuff like the provisioning profile, the info plist, the expo plist, which is used for expo updates, and some other stuff like Swift frameworks inside of here. All right, so now that we've taken a look inside of the IPA for seemingly no reason at all we have to do to submit the iPhone app to the App Store is to run EAS submit in our console. And we're going to select the iOS option. Now there is an Android option, but that can only be used for subsequent builds after you've already done one build manually like we just did. This is for automation reasons. Google Play doesn't have as much automation options as Apple does. So we're going to select iOS, and we're going to sign into our Apple account. It's going to ensure that the bundle ID is registered to our Apple account. It's going to create the app entry. So like what we just did in Google Play with the create button, it's going to do that automatically for us. And then we pick which IPA that we want to use. So in this case, we selected the latest one from EAS. So we didn't even need to download the IPA. And then it's submitted to the App Store. Now, it's going to tell us here that it takes about 5 to 10 minutes to actually see the binary in the App Store, and this is true. So when you go to visit this link right here, you're going to notice that the binary just won't be there. We'll get an email from Apple when it's actually ready to look at. But like a cooking show, I already did everything ahead of time. So we can go in here to the App Store, disregard my app names, and we can open up the app entry that was just created for us. So this wasn't here before. And you can see we can add stuff like our screenshots. We can add further metadata here, like the promo text, the keywords, the description. And then down here in the build section, we can select a build. So right here is our binary. All we have to do is hit done, and now our binary is ready to use. Another thing that we can do from here is up at the top in this App Store tab, we can select test flight. And if you want to do internal beta testing or just beta testing in general, you can do that from here. And you can select this binary, invite testers, and get to testing. And it's as easy as that. From this point, all you have to do is upload screenshots, do metadata, and submit it for a review. It actually came out recently that Apple rejects 2/3 of all new apps submitted. So you might need to do this process 1 or 2 times, but it was just 2 commands in the terminal. So it's pretty easy, and it's a little less heartbreaking when it happens. And that's it. We basically went from nothing to app in the Apple App Store and Google Play Store in less than an hour. It's never been this easy to do native app development before. It's extremely exciting as someone who just enjoys doing app development that I get to focus on writing React code and doing what I love, and I get to spend less time doing things like submissions and code signing and binary uploads. So I'm super excited to have shown you guys this, and now we're going to talk about an even more exciting thing than all of that, and that is over-the-air updates.
Assuming that you've built your app with Expo, you can redeploy your hosted JavaScript bundle to all of your users instantly, which is also known as over-the-air updates. Over-the-air updates are allowed in the App Store and Google Play Store as long as they don't completely change the functionality of your app. Over-the-air updates work in Expo just like they do in web development. You can create a production bundle of your React app and then upload it to a hosting provider. This can be done by running Expo Publish. By default, the bundle goes to Expo's free hosting service, but you can also self-host a bundle in essence anywhere you'd like. Offline first and a fast timed interaction are extremely important features in native apps. And because of this, Expo updates defaults to using a caching policy that always shows the downloaded bundle first. This means that if you push an update, the next time your user opens an app, they will still see the outdated cached version, but the new one will be fetched and downloaded in the background. The next time they open the app, they will see the new changes instantly. For web developers, this closely resembles the still while revalidate caching policy in service workers.
By now, you should have a reasonable understanding of how React Native compares to React DOM, the differences between Expo SDK and what React Native provides, how to add custom native code, and how to instantly send your app over the air to users. If you guys have any questions, comments, or concerns, run into any speed bumps or anything like that, we have some awesome forms at forms.expo.io that you can reach out on. If you have any feature requests, there's a React Native canny and an Expo canny that you can open feature requests on. And we're also present on GitHub at Expo and Facebook/React Native.
We hope that you've enjoyed it and that you feel a bit more comfortable now with starting native development. And if you have any questions, feel free to reach out to either of us. Thank you.
So now we're going to answer some of the questions that you guys had here. So the first one that I wanted to address was that there's this like Expo priority planning thing for EAS. So I was like considering mentioning it in the video, but I figured it wouldn't age well. But like when EAS is out of beta, then there's going to be like a free tier. So think of it kind of like how Firebase has the free tier, and then it has like the paid tiers, mostly for like corporations that have like scaled to a certain level. So the plan is to make it like co-operable with Expo Build. So people who are used to using Expo Build can just switch off into that and get the bundle size savings and the customization, things like that. But yeah, that should be coming out soon. The biggest blocker for adding that was adding managed support, just because we wanted to like limit the amount of usage while we were still working on it. But that's like pretty much out right now. So we're working on that pretty soon. But yeah, I didn't want to make it seem like I was just like, yeah, so here's this like paid only service, and this is the best way to, but yeah, it will be like a free thing.
You can go to ask a question.
All right, so I'm going to look at the kind of top rated questions that we have here. So the first one is, can you please talk about best structure for a large scale React Native application? Now, I don't think that there is there's not like a suggested like best like structure necessarily, not like, you know, Next.js has the pages directory and Create React Apps has like have a sources directory. I think what I've seen mostly is that people will end up having like a source directory in the root, and it'll have like screens and components and utilities. And then that typically scales. And that's like for these kind of medium projects and for the inside of your larger project. But then usually when people scale the project out even bigger, then they add a monorepo. And you can set up a monorepo with a package called Expo Yarn Workspaces, which is, I think it's like one of the best ways to actually set up a React Native monorepo. So like it uses Yarn Workspaces, and it's very easy to set up. You just add like some stuff to your package JSON, and then you can have a packages folder with like sub npm packages in your project, and then sub apps in your project as well. And then they can link between them. So you can keep code divided up nicely and like split out bigger, more like I don't know even how to describe it, like these more ubiquitous modules, and then use them across different apps. Let's see, the next question is, do you know when React Native's new architecture will be released, or the best source of information on when this question will be answered? So, I hope you guys have time. So things like Fabric and Turbo modules are already rolled into React Native as far as I can tell. I think like they are lacking on documentation, and there's not this very like clear picture, but there is the React Native proposals and discussions GitHub repo that you can like hop into, and there are issues there. And that's, in my opinion, the best place to see updates on this. And then there's also the a Discord for React Native developers. I don't know if it's like ridiculously public, but you can like, now that I think about it, there is not a Discord for React Native developers. But the discussions and proposals is usually what they discuss there. So I think that's the best place you're going to be able to get information on it. But as far as I know, like there's not like a lot of great resources on how to use it. When I've spoken to the team, they usually tell me to like look at the source code. All right, so actually, I think the best way to learn about turbo modules right now is to look at Reanimated 2 by Software Mansion team, because it's a very widely used, like kind of public, like React Native module, and they've done like a lot of incredible work with that. There's also like some cool like branch off projects like React Native. I think it's called React Native Multithread, which like lets you spawn JavaScript synchronously. So there's a lot of really cool like community things, but it's not like too expansive. So I would look at Reanimated. essentially just ask software management, don't know. Let's see, then, nice, reanimated 2 users in the chat. Let's see, for an existing RN Expo app, what is the best way to get started adding Expo web support? Any good tutorials, docs, or resources? So what we found with, well, if you have an Expo app, then web is just installed by default. It's very easy to set up. And I believe we have a doc, which is like adding web support to your project. The biggest part of adding web support was actually just adding web support to every single module and then adding web support to the Expo CLI, which is kind of a more like an Expo exclusive feature. So I would definitely recommend using Expo CLI. And then if you kind of want to have more like this SSR-based system, then using Next.js with your Expo web app is a really good like combination that we're seeing tons of people using. Fernando Rojo like uses that a lot, and he's built out a lot of that stuff. So if you're interested in doing something like Next.js with Expo, I would recommend you follow him on Twitter. All right, let's see what else we got here. Razzle's great too. Yeah, it's pretty good. By Jared Palmer. Oh, cool. Yeah. Then like another one's like any hints or reason behind React still sustaining when React Native could be run in web as well. Like, yeah, I think like React Native Web is a really good library made by Nick Gallagher, who's on the React core team right now. So I don't see that going anywhere anytime soon. And we at Expo are like super invested in React Native Web and want to keep rolling out. Do you see any questions here that catch your eye, maybe in the chat?
No, well, I'm looking for questions for you in the chat, but I think you've answered them all.
Any hint to incorporate the TensorFlow.js in Expo and possible links for learning more information regarding TensorFlow.js with React Native on finding no solution? So yeah, TensorFlow is actually like, it's built on top of Expo GL, which is kind of like the only real way to like do WebGL stuff natively in React Native without using like a web view. And so if you want to use TensorFlow.js, like you do like use it with Expo. And I do have like some examples for that on the github.com/expo/examples repo, or you could do npx create React Native app and then select a template. And I think we have like at least one template, which is like image processing. And so that has a demo of like how to set up Expo camera with TensorFlow and then like do image recognition with that. So you can also do like PoseNet and the facial recognition stuff. Let's see. First of all, thanks for this. I wonder what is the status of RN's new architecture? Okay, architecture again. Let's see. Software to run emulator on a local machine. Well, you can set up Android Studio, and I believe if you run npx React Native Docker, it has like a lot of good resources in that for helping you set up Android Studio to work on your machine. So I think that's like one of the best ways to get started with that. Otherwise, you can just set it up manually. What is the best way to bring Expo GL into a React Native non-Expo app? So this might answer a couple of the questions, which are like, how do you use any of the stuff that you just described without Expo? And essentially the way that like React Native works is, this is like a lot of like what Avocado touched on earlier, and that is that React Native is kind of like, it's a little bit more, but it's mostly like React DOM, but for native. So you have React and then you have React DOM or React Native that sits on top of that. And then you need like all these other libraries to work with it, but those libraries aren't like, they can work inside of Expo and inside of React Native. When we say like work inside of Expo, what we mean is like you're using maybe the Expo Go app, or you're using stuff in the Expo SDK, and anything in the Expo SDK can be used inside of any React Native project, and the Expo Go app can be used to run any React Native project. In the same way that Chrome can run any React DOM project, or any JavaScript library can be run inside of a React DOM project. So it is very cooperable. I guess my answer to this question is like, yeah, you can use Expo GL in any React Native project. You just install it in your project and set it up. But it is like, we do support that method. And essentially like with this new like run iOS command, all the stuff that we've been doing with config plugins, we had like managed workflow and bare workflow kind of over here, like living separately. But now like we kind of shifted in 41 where like the base of Expo is like built on top of Bare Workflow, and then managed workflow is just like a lot of helpers on top of that. And so at any level, you can just peel back managed workflow and just work directly in Bare. And the idea here is that whenever you start with Expo, you're not tied in to the Expo ecosystem. You can drop out and use any tool you want, which is why like I demonstrated with React Native Fast Image, like you can just install it and then do like Expo run, and now you've got your project running, and like you can just kind of co-op between anything that you want now. It's really flexible and awesome. Let's see, how can you use Next.js with React Native for web? They have a Next adapter, which helps kind of ease the transition between, all the configurations, like the Next config, the webpack config, things like that. I think webpack 5 support is still a little fuzzy, but we're also experiencing that just with our regular Next project. So there is some work to do there, but with regular Next.js, it works just fine. Is Bare Workflow the future? Yeah, so essentially, like I said, Bare Workflow exists now, and that's like what all of Expo is. And then on top of that, we have the managed workflow. So there's not this like black box system, and it's very easy to like just like pick and choose the tools that work best for you. And I think in the future, we're gonna have this more like fluid workflow, this like custom managed workflow where you can eject, and like even when you like eject or pre-build, like you can still make a managed build out of that. It just kind of ignores your iOS and your Android folders. Or it'll bring in your iOS and your Android folders, and it will like reapply changes on top of that, and then like use all the code. So we've really like done a lot to just like make it more fluid between the two workflows, so that you don't ever have to like really choose if you want to go down one path or the other path. It's just like you can go down the Bare Workflow path, but the managed workflow path is kind of like this ease of use system. You can kind of think of it like Next.js, where they have like you can do a lot of things custom, but it's awesome to just like let Next.js do a lot of the heavy lifting for you. And do you see any other questions here that you think we should answer? Coco?
What's your opinion on Flutter?
I'm not going to talk about that. Okay. Who cares?
No, I think you did great.
We did great together?
We did great answering those questions, yes. There's nothing better to hearing you talk about React Native.
Best way to build a multi-tenant application. I'm not actually sure what that is or what that means.
You're just Googling it now.
Yeah, multi-tenancy application. Yeah, not too sure. Where's
You can just answer it after the webinar.
Yeah, I'll answer it later. I can tweet you guys. What's the where's the host at?
Oh, where are they? They left us.
We're just like hanging out here now. Hey, what's up?
Yeah, I was just waiting for you to finish your monologue.
Oh, thanks. You sound like avocado, like every day, like academic table. Like.
No, I mean, if you have more time and you want to answer more questions, sure. If not, we can just leave them, and maybe people can tag you on Twitter and you can answer them later.
I can answer these audio problem questions. Did someone spill a drink on the MacBook? So we were using a software called like Loopback, which like takes your input and connects it to your output. So a video just goes directly in instead of playing and then coming out through your audio, so that it doesn't echo. And then like there was some issue with that and it just stopped working. So then we disabled that and we were just playing live, frantically.
Yeah, I guess this is what happens when you have those first timers, unexperienced devs on hosting a webinar.
Yeah. I've actually, I'm not, I don't interact with computers too often. Well, this is awesome. Thanks so much for having us. We really appreciate it.
Well, thank you. I guess this is it.
Yeah, I think that's it. We can also send you the raw video, so it won't have any of the audio issues.
Yeah, we will edit it out, everything that's happened that we didn't want. So the clear video will be on our YouTube. We probably can edit this thing here too. So yeah, thank you. Thank you, guys.
Yeah, awesome.
Thank you so much.
Take care. Thanks, everyone. Bye.